Okay, so now that we've done conversion from polar to Cartesian, which is pretty straightforward, right? Just plug in a few numbers and we're good to go. How do we go the other way? Now, the other way is more interesting. Sometimes it's obvious. Sometimes, we have to play around with it a bit. It also doesn't help that there's usually more than one option. Well, there's always more than one option in polar coordinates. But we usually try to pick the nice one. The nicest one, anyway. Anyway, so how can we start getting some equations to go the other way, right? So if we started with polar, we had the equations x equals r cosine theta, y equals r sine theta, that we could easily use to go, like, if we have the number for r and theta, we can easily get x and y. What can we do to go the other way? Well, here's where either some basic algebra or, some basic geometry, the Pythagorean theorem, or, some trig, all these things will sort of help you out here. If we look back at this picture up here, this triangle here is a right triangle, so it suggests an equation, namely Pythagorean theorem. So we get x squared plus y squared equals r squared. And this, again, follows from the, I hope I don't spell this wrong, Pythagorean theorem. Right? Another way you could do it is just take x squared and add y squared to it. You'll get r squared cosine squared plus r squared sine squared, and then you just remember your trig identities, right? Which they sort of come from this anyway. All right. So that's one way. So if we know x and y, we can get r squared and then take the square root of it. Remember, that does give you a positive and a negative value. So you're sort of free to use either one. Again, we usually try to go for the positive one just because it looks nicer, but sort of whatever works better for your situation. Theta's the tricky one, right? Why is it the tricky one? Well, we have to somehow use this information here to solve for theta. Well, what can we do? We want to somehow, get down to where we can solve for it. So if we look and say, well, take y over x. Why am I doing this? Well, let's see what happens. Write the equation for y, the value of x. Right? So what's going to happen here? These r's cancel out, and that's good news because we want to get r completely out of the picture. We want to just have theta. Right? This is now just sine over cosine, so that's tangent theta. Right? So we actually get two equations here, because we can also do x over y, which is going to end up giving us cotangent. Right? So we sort of wind up with three equations we can use. R squared equals x squared plus y squared. Tangent theta equals y over x. And cotangent of theta is x over y. Right? So, we do get these three equations. These two, either at least one of these will work at all times. Can you think of any problem that might happen with these equations where one works and the other doesn't? Wait a second there. So the problem can come in, well, what if x is 0? Well, then this equation's undefined, right? Because we have a 0 in the denominator. What if y is 0? Well, then this equation's undefined. So basically, we're going to use this if y is 0. We're going to use this one if x is 0. Right? And if neither of them are 0, then use whichever one you want. Now, if they're both 0, then you have to be at the origin. So r is 0, theta can actually be whatever you want. Every value of theta, if r is 0, corresponds to the origin. I'll let you think about why that's true, but it's probably best to just use 0, 0. Okay, so now that we know sort of how, or equation-wise, how to go back, let's do a couple examples and see how it really works out. Right, so example. So here we're going to go from Cartesian polar. Okay, so how do we do this? Well, let's look at the example -1, 1. Right, so remember this time this is x and this is y. So we know that r squared is x squared plus y squared. So this is -1 squared plus 1 squared. That's 2. So r, we can either use square root of 2 or negative square root of 2. So let's use just square root of 2. Right, so we square root this whole thing. All right. How do we get theta? Well, we can try and sort this out. So here we have tangent of theta is, let's see, this is y over x, so this will be 1 over -1. So tangent theta is -1. So here we have to know when is tangent theta equal to -1? Well, that happens when theta is either 3 pi over 4 or 7 pi over 4. Right? I mean, it happens at many, many places, but these are the sort of ones between 0 and 2 pi. How do we decide which one? Well, we can look at this point here and say, well, all right, x is negative, y is positive, so I know I have to be in the second quadrant. So it's got to be this. What else could you do if you're unsure? Well, if you're unsure, you could also plug this into cotangent theta. All right, plug this into that equation. This also has to be -1. If you think about where cotangent is negative, let's see, cotangent of theta being negative actually happens at the same places. Yeah, it does. Okay. So, what do we do if we're stuck there? Well, remember I said in the earlier video that these are also helpful for going from Cartesian to polar? Let's do that. We know that, say, -1 is r, so square root of 2, cosine of theta. This means cosine of theta is -1 over root 2, or, if you prefer, -√2 over 2. What theta values could make cosine take on this value? Well, your choices are, since cosine's negative, and this is the value of cosine pi over 4, we're left with 3 pi over 4, or 5 pi over 4, because those are where cosine are negative. And what you would do, if you wanted to go this route, is look for the value that shows up in both equations. Right? So let's do one more of these, just to kind of give you the picture here of how this goes. And I'll actually show it with my preferred method. I don't think the tangent cotangent stuff is the better way to go here. So what are we going to do? So we're going to start with 3 square root of 3, comma 3. Keep the numbers a little nice. So again, we'll say, all right, well, this is x and y. So r squared is going to be 3 root 3 squared plus 3 squared. This is going to be 27 plus 9. That's 36. And again, we could take the positive or the negative r value here. So either one actually works, but let's go with the positive one. Okay. Now that we have that, what I think a great idea is just use these every time. Use these equations. Because then you never have to worry about, oh, what if x is 0? What if y is 0? You can always use these. Just, you have to solve for r first, and then you have x, y, and r, and you can use that to get theta. So, what do we get here? We get 3 root 3 equals 6 cosine of theta. And here we get 3 equals 6 sine theta. So this is like saying cosine of theta is root 3 over 2. We simplify that. This one says sine theta is 1/2. Right? And now think about what value of theta makes both of these statements true. Okay? So this would be pi over 6. But just like last time, we could say, well, this means theta is either pi over 6 or 11 pi over 6. Right? Yep. Right? This one here, this says theta is pi over 6 or 5 pi over 6. And again, we just take the one that they have in common. So that the polar value is 6 comma pi over 6. I actually think I forgot in this last example, the polar was root 2 comma 3 pi over 4. Right? And there we go. So that's how you sort of convert between the coordinates. So again, Cartesian to polar is a little more tricky. A lot more options. Like, we could have used -6 and then theta would change to 7 pi over 6. Right, so just a couple other options. This is an option. Another option would be 6 comma 13 pi over 6, for example. Like, there's all sorts of options for this. And this is what I was saying about polar is not unique. But it is usually really helpful. Alright, so in the next video, we'll talk about graphing some polar equations.